welcome to another video tutorial for Ableton. Today we're looking at Operator. This is an Ableton device, and this is used for frequency modulation. So if you've ever been curious about frequency modulation or how it works, we are going to talk about that today and hopefully get you started so you can start making some cool music. Alright, so let's dive right into it. Let's start out by opening up a brand new MIDI track here, Command-Shift-T to get that going, and then coming over here to our instrument section, Operator, and get ourselves a new initialized device, just the default setting. Alright, so right away, let's break this down. We have the left section over here, which is all of our oscillators. We have 4 of them, A, B, C, and D. We have the middle section here that is a graphical interface that changes between different settings, and we can see our envelope settings for the amplitude of each oscillator, so we can see that there. Each of them have their own envelope and then oscillator settings, so we can change the waveform. We have a bunch of presets here: sine wave, saw wave, square, triangle, noise, and then a user defined, which is pretty fun. So we can actually go back down here to the A and just draw in our own frequencies, and we can see our waveform actually changing as we affect. So we have a nice little graphical image of that. So we can see how that gives some pretty interesting sounds, even just with the user-defined waveform there. Okay, so that's the middle section. And moving over here to the right, we have a few different things, an LFO, and we can assign that to the actual pitch of oscillators, or we can have a user-defined setting. So we have all these options here. And here's what that sounds like. Pretty standard. Got your amount knob. And then you have a low setting, a high setting for the actual rate of the LFO. So this actually, the high gets into our audible frequency spectrum, and that's actually another frequency modulator right there, just set at a predefined rate. And then sync will actually sync up with our tempo of the song. Whatever you have your global tempo set to up here. All right, moving on from there, we have our filter, pretty standard. Envelope there. And we have a nice kind of a graphical interface for that if we don't want to use the knobs here. Okay. So we can hear that affected there. Let's get something a little more harmonic content as we play around here. All right, there we go. So coming to, and then next we have a pitch envelope as well, which is pretty cool. So an envelope dedicated to affecting the pitch, right? And to have that affected, we just got to turn up our envelope amount. Or we can go in reverse. Okay, that's pretty cool. And then finally we get to the algorithm section, which is really where all the magic is happening. Here we can see we have highlighted the first algorithm, which is a inline setup, and this is actually called a stack algorithm. And here's how we take advantage of these algorithms. With this inline, basically what we're saying here is that the bottom oscillator is the carrier. It is what is being modulated by the ones above it. And what's actually being modulated is the frequency of the carrier, which is determined by the frequency of the modulator. So in this instance, the carrier is A, and the modulators B, C, and D. B modulates A, C modulates B, and D modulates C. So when we turn up the volume of B, what's happening is that this is the amount at which B's frequency is affecting A's frequency. So in this case, the two oscillators on top are both modulating the green oscillator, oscillator B, and then down the chain. This one has actually two branches, so this would be a branch algorithm. And then we have root algorithms, so they have multiple carriers affected by one modulator or modulator stack. Here we have like two carriers, one is a stack and then one is just carrier only. And then finally we have algorithms that they don't modulate each other. They're all independent of each other. So if we want to get a really broad sound with that and not so much frequency modulation. But remember, you can always set your LFO to be a frequency modulator itself if you set that in the high spectrum there. Cool. So let's hear how this actually affects the sound. Turn off that pitch envelope here. So we just got a saw. And as we add in the B's level, let's get that back to a stack. As we add in the B level, we can hear the timbre change. Put our frequency all the way. Down a bit. And so since B affects A and then C affects B, we would not hear the effect of C unless there's information or there's level coming out of B. And then likewise, D affects C. And that's when we really get into some crazy sounds. And we can even come over here and turn down our coarse knob, and that actually halves the frequency of this oscillator. This works in multiplications of the fundamental frequency, whatever that you're playing on your MIDI keyboard. So 1, that's going to be your root. 2, it's a multiplication of 2, so that's double, and that is an octave above. And then you have to go to 4 to get 2 octaves above, 8 for the next octave, and then 16, and so on and so forth. So if we go to half, we can get an even lower tone there. We can switch up our waveform. Kind of just play with these levels. No real idea of exactly what I'm going for, just kind of listening, using my ear. And so I can have these amounts be affected over time. So that's pretty cool. We can get that there. And we can maybe have this one decay, right? And the loop is fun too. So it's just repeating over and over again that envelope. Pretty cool stuff there. So you can see we can get some pretty interesting sounds very quickly. Awesome. All right, so let's move on and see what we got here. As I was saying, we have different types of algorithms that we can use, and I'm featuring the stack algorithm on this patch. Turn off the arpeggiator on all my devices here so we can get a raw sound. So this one features 2 carriers and a modulator for each. So if we mute C, we're not going to hear D because D is modulating C and B is modulating A. So we're only hearing A right now. And here's what the C stack looks like. So kind of combining two things in one. Next, we got the branch algorithm going for our bass. And I have set on here an LFO from Max for Live, just to affect that level by itself. Because I have the internal LFO doing another job, kind of affecting a little bit of rhythm, giving a little character. Pretty cool stuff there. And a root algorithm. You see here we got two carriers being affected by one modulator stack. And then finally we just have a carrier only. And what's unique about the carrier only, when you only use carriers by themselves, not with a frequency modulator, you can actually self-modulate them. And the way that we do that, coming over to the oscillator that we want to self-modulate, and we come into the oscillator section here and we turn up the feedback amount. So this will actually now send its own signal back into itself to modulate. Let's hear how that sounds. Whoops. Let's turn off our arpeggiator here. So you can hear we're getting a little grit on there. Turn that up a bit. Pretty minor difference on this one. We can try a different one to self-oscillate, or self-modulate, excuse me. And for here, since the carriers are being modulated already, you can see that's grayed out, so that's not going to affect itself. It's only when a operator, that's what these are called, the oscillators, or operator in FM synthesis world, they're called operators. Only operators that are not being affected or modulated will have this feedback option available. Not hearing a lot of change there. Sometimes that's just how it happens. All right, so that will do it for operator. I hope you learn the basics of it and can get out there and start making your own music. Good luck.